Hey, what's up everyone? I hope all of you are doing great. And in today's question, we have two ideal inductors, each of inductance L connected in series, and then a capacitor of capacitance C is connected in parallel to one of the inductors. This combination is connected across a series combination of an incandescent lamp, okay, and a variable frequency alternating voltage source. It has been observed that the lamp glows with minimum brightness at angular frequency omega. At what angular frequency will the lamp glow with maximum brightness? Fine. So let us redraw the diagram once again. Capacitor, bulb, and the voltage source. Fine. So as in the question, it is given that the brightness of the bulb will be minimum for an angular frequency omega, and we need to find out the angular frequency when the brightness will be maximum. So here brightness will be minimum or it will be maximum, it totally depends on the impedance of the whole circuit. Fine. So ultimately we need to just check for what frequency the impedance of the circuit will be minimum or maximum. Okay, so here we will take the help of complex numbers. Okay, as I have said earlier that normal people use phasor diagram, but legends use complex number. Anyways, so let the impedance of the inductor be XL, XC, and this one will also be XL. Fine. So these are the reactances, and there will be some resistance for the bulb. So if we write the whole impedance in complex form, so we need to write R plus JXL, because for inductor we need to write the impedance like this, and for capacitor the impedance becomes minus JXC. Okay, so these two are in series and these two are in parallel, so plus JXL minus JXC divided by JXL minus JXC. Okay, so just simplify this expression, JXL minus J times XL XC divided by XL minus XC. So finally it will become J XL minus XC, XL minus XC minus XL XC. Okay, so R plus J XL XC XL square minus 2 times XL times XC. So this is the final form of the impedance in complex order or in the complex form. Fine. Now we know that mod of Z, that is the total impedance of the circuit, would be R square plus minus 2 XL XC divided by XL minus XC whole square whole to the power half. Fine. Now as in the question it is given that brightness is minimum when angular frequency is omega. So for minimum brightness, that means for minimum current through the bulb, the impedance must tends to infinity, and this will happen when this denominator will tends to 0, that is XL minus XC will be equal to 0. So omega L will be equal to 1 by omega C. So the frequency for minimum brightness is 1 by root LC. Now we need to find a frequency for maximum brightness, that means for maximum current flowing through the circuit, and this will happen when the impedance or the magnitude of the impedance will tends to R, that means when the circuit will be in its resonance condition, and during resonance condition the whole imaginary part of the impedance will just get vanished. That means the numerator will become 0. So the numerator is xl square minus 2xl times xc. So xl square xl times xc will become 0 for some given frequency. Let that be omega prime. So xl equals 2xc. So omega prime L equals 2 times 1 by omega prime c. So we have omega prime equals root 2 divided by root over LC, that is root 2 omega. That means for a frequency of root 2 times omega, the current through the whole circuit will be maximum, hence the brightness of the bulb will also be maximum. So I hope you all have found this video helpful and informative. If you are new to this channel, please do subscribe, and see you in the next video. Good luck, peace.